This method of factoring is called factoring by grouping, and I'm going to try this method whenever I have 4 terms. So if I have 4 terms, I'm just going to go ahead and try and stick everything in the box and see if I can get it to work out. So once I have everything inside, so I'm going to put it in just as I see it and start factoring out the GCF of the top row. So if I look at 5x cubed and negative 10x cubed, they're both divisible by 5, and they both have at least an x squared. That's going to allow me to find the top and fill in the rest. If everything works out, so 3 times negative 2 is negative 6, the whole box works out, then my two factors are 5x squared plus 3 times x minus 2. If I want to factor this, I am going to notice that this has 2 perfect squares in it, and one of them is negative. So I can think about this as x to the 4th minus 25, and when I do that I realize that this is simply a difference of squares problem. And if you remember from what we learned in the quadratics unit, if we have difference of squares, we can just go ahead and write our factors down. Take the square root of the first term, so if I take the square root of x to the 4th, I get x squared. And if I take the square root of 25, we get 5. One's going to be a plus, and one's going to be a minus. And then from here, I just want to check and make sure I can't factor further. So particularly because x squared is a perfect square and because there's subtraction, I just want to double check and make sure that the last term in this factor is not a perfect square. 5 is not a perfect square, so I know that I am finished. Here's a bonus if you've watched so far. This is a question on your homework. If we have x to the 6th minus 100, this is actually a difference of squares problem. X to the 6th is a perfect square. If I think over here to the side, x to the 6th is really x cubed squared. So it is a perfect square. I can write my 2 sets of parentheses, take the square root of the first term, which is going to be x cubed, take a square root of the second term, which is going to be 10. 1 is a plus, and 1 is a minus. Now, when I look at this, I'm going to check a couple things. I'm going to check and make sure I don't have any other difference of squares. X cubed is not a perfect square, so I'm good there. And I also need to check and make sure I don't have sum or difference of cubes. X cubed is a perfect cube, but 10 is not. So we know that we are finished.